Alright, so this section of my graph is decreasing because it's going down, and then from this point right here, from 2, it starts to increase back up. So I would write that it's from negative infinity all the way to 2 is decreasing, and then from 2 all the way to positive infinity is increasing. When I want negative and positive, this one's going to look a little different. So negative means it's below the x-axis, so anything below. So from this point all the way down, all of these are negative because they're below the x-axis. So I'm going to write 3 sections. I have negative infinity to about 0.2 is this section of my graph. Then I have from 0.2 all the way to we'll say 3.8, I'm just estimating. And then this piece of my graph that's up here would be from 3.8 to positive infinity. Now I have to just choose. The middle piece is my negative because it's below the graph, which means this piece over here is positive and this piece is positive because they're both above the x-axis. They're in the positive values. Domain are our x values, which means all of these x values, when I plug them in for my quadratic, it'll be negative infinity to positive infinity. And for the range, it will be from, it doesn't touch negative infinity. It touches at -3, and it goes all the way up to positive infinity for the range. Given the equation, consider the domain for the function that is positive. Okay, so that means when I look at this graph, I want to know where it is positive. So if you wanted to graph it on graphing paper, you could. If you want to make a number line, my x-intercepts would be at 15 and positive 35 because x would equal 15, x would equal 35. If I think about my graph, it would open down because of the negative. So if my graph is opening down, that means up here is going to be positive. That means this section in the middle is positive. So my domain would be from 15 all the way to 35. I would be making a positive amount. If I wanted negative, then it would be the opposite. It would be the outsides. Another way you could do it is if you wanted to check the center, plug in a number. So plug in like 20. Plug it in. And then you would see if it was true or false. Like on homework 2.10, if you want to review that. Find the average rate of change on the graph from x equals 0 to x equals 2. So when x is 0, y is -4. When x is 2, y is +4. That's nice. Average rate of change is the same thing as slope. So So we'll do y minus y over x minus x, y minus y over x minus x, negative 8 over negative 2 is a positive 4. That would be my rate of change. Graphing standard form. Graph f of x equals negative x squared minus 2x plus 15. I would find the vertex. Negative b over 2a equals negative, a, b, c. Negative b would make that a positive over 2 times negative 1. 2 divided by negative 2 is negative 1. That's my x. I plug it in to find my y, which would be plus 2 plus 15, which would be 15, 16, 17, 1 is 16. I plot that vertex, and then from there, it would open down by negative 1, negative 3, negative 5. So it would look like this. You'd go negative 1, up 16, pretend that's 16, it's not there right now. Then I would go down 1 over 1, down 3 over 1, down 5 over 1, and I would graph my parabola. What are the zeros and the axis of symmetry for the function 2x squared minus 8x? To find that, I can, zeros mean x-intercepts, so I need to solve for x. I can either do standard form, so a, b, c is 0 and plug it into the quadratic formula, or I can factor it. I'm going to try and factor it. A 2 is the GCF of the 2 and the 8, so I can take a 2 out. They both have an x, and then what's left over is an x minus 4. That means that x equals 0 and x equals a positive 4. If I wanted the axis of symmetry, that means symmetry means that it's 2 equal parts. So if I want the axis of symmetry, that means the line that goes right down the middle of these 2 intercepts. The middle of 0 and 4 would be 2. So the axis of would be x equals 2. Rewrite x squared plus x minus 20 in intercept form in order to identify the zeros. Intercept form is the same as factoring. So if I factor it, I get an x and an x in front. Multiples of 20 are 4 times 5. I want a positive one, which means the bigger number needs to be positive and the smaller number is negative, which means my zeros are, to move this away from out of the factor would be a positive 4. You'd have to add it to both sides. And to move the 5 away from the x, you would need to subtract it. Those would be the zeros from factored form. Which of the following functions has a greater average rate of change over the interval 2, 4? So in order to find that, I need to plug in a 2 for x. 2 squared is 4, minus 1 is 3. 4 squared is 16, minus 1 is 15. Then I just have to find the slope. Y minus y over x minus x, 12 over 2, which equals 6 for my rate of change there. Or, this one didn't get typed in. I'm just going to make a table and say 2, and make it really easy. Alright, so I need where x is a 2, that would be this one, and where x is a 4, and then I find the slope. So I would do y minus y over x minus x, negative 2 over negative 2 is a 1. Which one has the higher rate of change? 6 would be the greatest average rate of change. It's increasing faster. Create a formula using substitution. So I'm going to plug in all of these values into its place so that Rn is equal to, I plug in Pn, which is n squared plus 3, times Sn, which is an n, plus Cn, which is 5n minus 8. And I simplify it. This one is multiplying, so I have to distribute. N times n squared is n cubed plus 3n. And then I have to distribute this positive into this set of parentheses, so plus 5n minus 8. These two terms are like terms, so I can combine them into 8n minus 8. And then you have solved for the function Rn. The graph of the functions f and g are shown. What is the value of k above if g of x is f of x plus k? I'm going to show you online what this will look like.